Lesson 25, Pressure at a Depth. In this lesson, our objectives are going to be able to understand that pressure increases with the depth below a fluid. You will also want to be able to calculate that pressure below a fluid. So, pressure at a depth. You know from the previous lesson that we experience pressure from the air around us. Remember, air is a fluid, and gravity is pulling that fluid of air down on top of us. The more air above us, the more pressure we feel. So, because we experience pressure because of the fluid of air, if we were to go below another fluid, like water, gravity is now pulling not only the air, but the water down on top of us. So the further you go below any fluid, the pressure is going to increase because of the weight of that fluid. The way that we can figure this out is with a relatively straightforward formula. It looks like this. Now, this formula may look a little bit intimidating because it has a lot of different things in it. But it's really not that bad because you know what most of these things are already. On the right-hand side of the equation, we first have P with a subscripted O. That is representing the outside pressure, the pressure that you're already experiencing because of the air. That needs to be in pascals. Capital D is something that we've seen already. This is the density of the fluid. Now, since the density is going to be used with a lot of other things, we have to be in our fundamental or basic units. So the density is going to have to be in kilograms per cubic meter. G is something that you have seen already as well. G is 9.8 newtons per kilogram, or gravity. Lastly, we have D, which is the distance below the surface of the fluid, or the depth of the fluid, that has to be in meters, our basic unit. You're going to want to put this on your formula card underneath mechanics because it does deal with pressure. You will want to label it pressure at a depth to differentiate it from the formula that you just have for pressure. One other thing to take note of is the plus in the middle of the equation. Many students make mistakes because they multiply everything on the right-hand side. Make sure to follow what the formula is telling you to do. One other thing to note, and you can also write this on your formula card, is that since most of the time the fluid that we're going to be under is water, you're going to want to know the density of water. Most problems will assume that you know that the density of water is 1,000 kilograms per cubic meter. Let's take a look at an example. What is the pressure on a diver swimming below 2 meters of water if the outside pressure is 1.013 times 10 to the 5th pascals? So we start as usual by identifying what it is we're looking for. What is the pressure? Now that's something that you did in the last lesson, so now you have to make sure that you read the problem carefully. This is asking for the pressure below. So now that since we're asking for the pressure below, not just pressure, but pressure underneath a fluid, you're going to want to use our new formula. So the first thing that we need is our outside pressure, which is 1.013 times 10 to the 5th pascals, and it is in pascals, which is what we need. The next important thing is we need density. Well, it doesn't tell us a density in the problem, but it does tell us that we have water. And as I said, problems are going to assume that if we have water, since water is the most common substance that we're going to be below, that you're going to know that the density of water is 1,000 kilograms per cubic meter. Next in the formula is gravity, which is 9.8 newtons per kilogram. And then our depth, 2 meters. Now we can substitute these values into our equation. Notice a couple things about the substitution. First, I put the units in. That's going to help us a little bit later on to see how we're going to get pascals out. I also highlighted the plus in the middle of the equation to remind us that we need to add these, not multiply everything. So we're taking the outside pressure plus the product of the density, gravity, and depth. Now when we put that in the calculator, we get 120,900. On the previous slide, it did say that our answer is going to come out in pascals. Let's see why. On the rightmost side of the equation, when we're multiplying, we can see that we have kilograms in the numerator and the denominator. So they're going to cancel. We also have 1 meter in the numerator and a meter cubed in the denominator. So they're going to cancel and give us a meter squared. So we end up with a Newton per meter squared, which is the same thing as a Pascal. So our unit is a Pascal. So now you can see that the pressure below a fluid does increase the further down you go, and you can calculate it.